A bar of 600 mm long is having a square section of 50 mm by 50 mm. So we have a square section which is B, which is 50 mm, and D, which is equal to 50 mm. It is a square cross section having length will be equal to 600 mm. If the bar is subjected to an axial load of 120 kN, so it is along the x direction. So we have an axial load of P1 which will be equal to 120 kN. That is, on this side also you will going to have 120 kN. And lateral compression load of 600 kN on faces of sizes 50 mm by 600 mm. So lateral compressive load P2, which will be equal to 600 by 50 mm on face, you will going to have a compressive load of 600 kN. And also similarly lateral compressive load in the z direction, so this is in the y direction, which will be y here, and compressive load of in z direction, which is again P3, will be equal to 600 kN on the faces of 50 by 600. So this length is 50, this width is 50 and this length is 600. So this is how you will be able to analyze this problem, find the changes in size and the volume of the rectangular bar. So first we are going to take up strain in the direction of xx, or stress in the direction of xx, in the direction of xx. So what is going to be the value? Since it is stress which will be equal to sigma x, so the general term for this is P by A, that is load by the area of cross section. So that means load in the direction of xx, load in the direction of xx, so in bracket I will write that value as P1. So that is divided by area of cross section, area of cross section perpendicular to the direction of P1, perpendicular to the direction of P1. So that means you will going to have this value here, which is 120 kN acting perpendicular to this area, so which is 50 by 50 mm. So now it will going to be sigma x, what is the load applied, which is 120 kN, which will be 120 kilo means 10 to the power of 3 divided by the area of cross section perpendicular to the load applied. So which is that B is 50 and this is also 50. So this is the cross sectional area what we are talking about. So that will be equal to 50 into 50. So that will be equal to 48 Newton per mm square, 48 Newton per mm square. So this is the stress. So since it is along the direction, that is the tensile load, so we will going to have the tension. So it will be a tensile stress. Now we will going to take the stress in the direction of y1. So when you are considering the stress in the direction of yy, stress in the direction of yy, which will be sigma y, again which is P by A, again which is equal to sigma P by A, that is load in the direction of xx of yy. So load in the direction of yy in the direction of yy. So what is the load applied in the direction of yy, which is P2, and divided by area of cross section perpendicular to the direction of yy, perpendicular to the direction of P2, that is the load applied. So which is the direction now we are talking about? It is a compressive load. So we will going to have this which is the 60 by 600 by 50. So that is the area of cross section. Therefore sigma y will be equal to, we say 600 kilonewton, so 600 into 10 to the power of 3, which is the area of cross section, which is 600 into 50. So 600 into 50, so that will be equal to, so 600 kilonewton or Newton, 600 kilonewton. So it is, so 6. So here it will be 6 kilonewton. It's not 600, it should be 6 kilonewton. So this will be 6 kilonewton of heat is 600. Oh, yes, it is only 600. So we will be having the 600 kilonewton here. So this is also 600 kilonewton. So once we have this, so here which will be 600, 600 get cancels. So here 10 to the power of 3. So that means 1000 divided by 50, which will going to be 20 Newton per mm square. So the next is we will be having the next is sigma z, stress in the direction of zz, stress in the direction of zz, in the direction of zz, which will be again sigma z. Again it will be equal to load in the direction of zz, load in the direction of zz, in the direction of zz, which is P3, divided by area of cross section, area of cross section perpendicular to the direction of P3, perpendicular to the direction of P3. So now when we are considering this, load in the direction of zz, so load in the direction of zz is this, applied by the area of cross section perpendicular to that. So that will be the value which we are considering, which is 600 by 50 again. So load in the direction of zz, which will be 600 kilonewton. Therefore sigma z will be equal to 600 into 10 to the 3 divided by area of cross section, which will going to be 60 or 600 into 50, which will be equal to, again it will going to be the same value, which is going to be 20 Newton per mm square. So what is the nature of load which is applied? The nature of the load applied is compressive. So here also this will going to be compressive, and here also it is going to be compressive. So this is how you will be able to find the stresses in each direction. Now we will going to take up the strain in the direction of each value. So strain in the direction of xx will be equal to now we will be having the strain in the direction of xx. Strain in the direction of xx, which will be epsilon x will be equal to sigma x by e divided by minus sigma y by m into e minus sigma z by m into e. So this is the general equation. Now when we are considering this, we will going to have sigma x by e. So the minus sigma y by m into e, because we have compressive here in sigma y. Again minus sigma y by m into e. So sigma z by m into e. So that will be equal to sigma x by e plus sigma y by m into e plus sigma z by m into e. So that will be equal to sigma x by e plus 1 by m into e into sigma y plus sigma z. So now we are going to apply this because the positive sign due to the compressive stress. So this is how we are going to get this value, because it is minus into minus, it becomes plus. So now, therefore, we will going to have epsilon x will be equal to what will going to be the value of epsilon x? We have sigma x. Sigma x is 48 into 10 to the power 48 divided by 2 into 10 to the power of 5 plus 1 by m into e. What is 1 by m? Which is 0.3. 1 by m by 0.3 by e, that is 2 into 10 to the power of 5 into sigma y, that is 20 plus 20. So that will be equal to 3 into 10 to the power of minus 4. So that is the value of epsilon x. So this is going to be the value of epsilon x. So once we get the strain in the x direction, therefore now we are going to find out the delta I, that is change in length. So to find out that, therefore change in length will be equal to change in length, which is delta L, will be equal to epsilon x into the original length, which will go to be L. So that will be equal to, so that is 3 into 10 to the power minus 4 into length of the member. The length of the member is 600. So that will be equal to 600. Therefore, delta L, which is the change in length, which will be equal to 0.18 mm. Since it is tensile, so naturally this is going to be the increase in length. So this is how we will be able to find the change in length of the member, the rectangular bar. Now we will going to consider strain in the y direction. So now the strain in the y direction, which is going to be strain in the y direction, strain in direction of yy, which is epsilon y. The general term will be equal to sigma y by E minus sigma z by m into E minus sigma x by m into E. So this is the general term which we are talking about. So when we are considering this, so as it is we have epsilon y, so sigma y here in this case it is negative, so minus sigma y by E because it is compressive. Then again minus of minus sigma z is compressive, here this is minus, so you will going to get sigma z by m into E. Again here minus sigma x by m into E. So that will be equal to minus sigma y by E plus sigma z by m into E minus sigma x by m into E. So that will be equal to, so when you are considering this, we can consider minus sigma y by E. So when you are taking minus sign as the common factor, minus 1 by m into E, then what happens? You will go to get sigma x here and then plus. So here, since we have plus here, so this will be minus sigma z. So when you are opening up, you are going to get minus sigma x by m into E, and also minus into minus it becomes plus. So it will be plus sigma z by m into E. So now we are going to apply these values. So epsilon y will be equal to minus 20 by 2 into 10 to the power of 5, then minus 0.3 by E 2 into 10 to the power of 5 into 48 minus 20, that is sigma x minus sigma z, which will be equal to minus 1.42 into 10 to the power of minus 4. So that is the value of epsilon y. And also epsilon y is given by the width, that is delta b by b, which will be minus 1.42 into 10 to the power of minus 4 is equal to delta b by b. B value is 50. So therefore change in width will be equal to change in width, which is delta b, which is negative sign is indicate that it is a decrease in width. So that will be equal to minus 1.42 into 10 to the power of minus 4 into 50. So that will be equal to 7.1 into 10 to the power of minus 3 mm. So since there is a negative sign here, so we have a negative sign. So that negative sign indicates that it is decrease in width. So we have the decrease in width. Now we are going to take up strain in the direction of ZZ. So to find the strain in the direction of ZZ, strain in the direction of ZZ now. So strain in the direction of ZZ, which will be sigma epsilon z. Again we have sigma z by E minus sigma x by m into E minus sigma y by m into E. So here this will be sigma z, in this case it is compressive, so minus sigma z by m into E, then sigma x is tensile minus sigma x by m into E minus again sigma y is compressive, so minus sigma y by m into E. So this is the value. I am just substituting the values here. So that means minus sigma z by m into E, sorry, sigma z by E, so minus sigma z by E. So here minus sigma x by m into E, minus into minus will become plus sigma y by m into E. So that will be equal to minus sigma x z by E. Then when we are considering this here, which will be minus by minus 1 by m into E. So when you are considering minus, you will going to get sigma x minus sigma y. So here what happens? Minus sigma z by E. So you are going to get minus sigma z by E. So I am taking minus 1 by m into E as the common factor. When you are considering this, you are going to get plus sigma x minus sigma y. So when you open it, you are going to get minus into minus becomes plus sigma y by m into E. So now we are going to apply the values here and get the equation or get the values. To get that, so here, so we have epsilon z which will be equal to epsilon z which will be equal to, so sigma z is minus 20 into 2 into 10 to the power of 5. Then again minus 1 by m is nothing but 0.3 by E. So 0.3 by E, again 2 into 10 to the power of 5 into sigma x value. Sigma x is 48 minus 20, which will be value is minus 1.42 into 10 to the power of minus 4. Also what we have is epsilon z. Also epsilon z, which is the z direction which we are talking about, which is the compressive. So which will be delta d by d. So that is delta d by d. That is we will have, which is minus 1.42 into 10 to the power of minus 4, which is equal to delta d by d, which is equal to 50 because it is square cross section. Therefore, change in diameter, change in depth, which is delta d, change in depth, which is delta d, will be equal to minus, so which will be delta d, which will be equal to minus 1.42 into 10 to the power of minus 4 into 50, which will be equal to 7.1 into 10 to the power of minus 3 mm, which is decrease in depth. So that is basically because we have a negative sign here. So this is how then we are going to be changing the lateral dimensions. Now we will going to find out the volumetric strain, change in size. Now we are going to take up the volumetric strain. So what is going to be the volumetric strain? Volumetric strain, which is epsilon v, will be equal to volumetric strain, which is epsilon v, which will be equal to epsilon x plus epsilon y plus epsilon z. So here, so epsilon x is nothing but 3 into 10 to the power of minus 4. Then plus means negative 1.42 into 10 to the power of minus 4 minus 1.42 into 10 to the power of minus 4. So that will be equal to 0.16 into 10 to the power of minus 4, which is a positive value. So therefore change in volume, change in volume, change in volume, which is delta V, change in volume delta V will be equal to epsilon V into V. So what is epsilon V? Epsilon V is 0.16 into 10 to the power of minus 4. So delta V will be equal to 0.16 into 10 to the power of minus 4. It is the volumetric strain into the original volume of the member, which will be 600 into 50 into 50. Therefore, change in volume delta V will be equal to change in volume delta V will be equal to 24 mm cube. Since it is a positive value, therefore we will going to have the increase in volume. So this is how we will be able to find out the values.